Now that we've discussed limits for functions of multiple variables, it makes sense to discuss the continuity using the definitions that we have for limits. So when we think about a function of multiple variables, we say that it's continuous at some point x0, y0 if the function at that point is defined and the limit of the function as the inputs go to that point are equal to the value when you plug in directly. So it's the same idea as in what we did with introductory calculus, those types of limits, where you just say, all right, well, if the function approaches it, and when I plug in the value as opposed to using the limit, if they get the same answer, then I know that it's continuous there. And that's pretty much it. So in terms of properties, you get the same properties of continuous functions that you get in single variables. In multiple variables, you get the same thing. Anyway, so if you have two functions and they're both continuous at some point, then what we find is that any scalar multiple of that function is also continuous at that point. So 10 times that function is continuous, which again is something you probably would have expected. Also, you can either add or subtract two continuous functions, and that is also guaranteed to be continuous. So it's very common that you have some sort of like polynomial, right? You have multiple pieces added together. If each piece is continuous, then putting them all together is also continuous. Similarly, if you multiply two continuous functions together, their product is also continuous, which is very convenient because it says if I have two things jammed together, if I know this is continuous and I know that's continuous, I know that that multiplication is also continuous. And then finally, division is continuous except in the case where at that point it's equal to 0, which is what you might expect. Dividing by 0 gets you, that's an undefined quantity, so continuity doesn't really happen there. So in general, these are all the same properties that you would expect from functions of single variables, but they also happen to apply to functions of multiple variables.